Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is an interesting MCQ, and you can see here asymmetric carbons are there. So it is a little difficult. So I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box. Don't worry, after some time you will have the right answer with explanation. I believe you have tried, so let's start. Now today's discussion is going to be a little interesting, student, because reaction is there and stereochemistry is there. So this makes the problem interesting. So let's go step by step. First, if you have bromine and you are reacting with magnesium metal in anhydrous THF, what it will result? Very simple, Grignard reagent. So in this case, student, I recommend go step by step. That is better. Okay, so this is alkyl magnesium bromide. By the way, Grignard reagent, if you look at this Grignard reagent, carbon atom is attached to magnesium. By nature, carbon is more electronegative compared to magnesium. So this carbon is delta negative, magnesium is delta positive. Similarly, you can say, sir, there is a magnesium bromine electronegativity difference, and bromine is actually a halogen atom, so it should be delta minus. Obviously true. But question, both two delta minus centers are there. One is bromine delta minus, another is carbon delta minus. So who will react? Next question, who is more reactive? By the way, if you look at this Br, by nature, it's actually group 17 element halogen. So it prefers to have electron density on itself. It's a very high electronegative atom. So you can say electronegative atom got extra negative charge, means delta negative. So it is actually a relatively more stable. But if you look at carbon, it is actually neither electronegative nor electropositive. It belongs to the in-between. Remember, I told with respect to magnesium, carbon is more electronegative, but it doesn't mean that carbon itself a highly electronegative atom. Okay, magnesium is a very high electropositive atom. So that's the reason. Now here, carbon have extra electron density. So this is the reason of its reactivity. More specifically, if I say its nucleophilicity, because it has extra electron density and it is not that much comfortable to have this electron density. So what it does? It can act as nucleophile, means it can attack someone. Now where it will attack? That answer is given in the next step. So this is your reagent A. Now in the next step, where? So here you can see there is a 5-member epoxide. By the way, this epoxide is actually a chiral. Okay. Now if you look at this epoxide is a 3-member ring, and this oxygen is attached to this carbon and this carbon. So let me number add, this is 1, this is 2. Arbitrarily I am numbering. Now if you look at, oxygen is more electronegative atom, means it will pull the electron density from this covalent bond. So obviously this will be delta minus, this carbon will be delta plus. Obviously here it will be delta plus. Now delta plus means this is electrophilic. Both delta plus are electrophilic in nature. Now obviously I have a delta minus nucleophilic center, so nucleophile, electrophile, they'll react happily. True, but there is a twist. Now question, both 1 and 2, they are not same carbon. So where the nucleophilic attack will take place? Now here the question comes about the bulkness. Bulkness will decide the regioselectivity. Now if you look at here, this carbon, it is a tertiary carbon. But this carbon, if you look at, it is a secondary carbon. So obviously this is less bulky. So the incoming nucleophile, I mean the secondary butyl anion type of thing, faces less kind of steric repulsion if it attacks here. So actually it will attack, but again, from which side? If you look at this, oxygen is on the top side, agree? So consequently these will attack from the bottom side. Very important. So it will attack from the bottom side and this bond will open. Now student, when such kind of situation appears, I recommend draw as it is. Do not change anything. So okay, this is my 5-member ring. Now this is my oxygen above side. Now it opened up, so it is O minus, and whatever methyl bottom, this is bottom. Now look at these alkyl group, this butyl, secondary butyl, attack from the bottom side, so it will be like this. Agree? So this will this will be the product. Now next step is obviously workup. So draw as it is. Now student, I know you'll say, sir, your drawing is bad. Agree, I'm drawing in a plastic board. But I suggest you please draw it in a pen and paper. Otherwise, understanding stereochemistry is significantly difficult. Okay, so this is the product. Now I know you'll say, sir, it's pretty easy, but initially it looks like very difficult. Yes, some problem you need to follow the mechanism, you need to write step by step, then life became easier. So what thing we understand, actually remember this epoxide opening, so this nucleophile got bottom and this OH top side, so opposite, and position of methyl is there as it is. Now if you look at what is the answer, obviously this is top bottom, this A is the answer. Now if this question appears in your exam less than 30 seconds, how can you solve? Very difficult, frankly speaking. For that purpose you need to have a lots of practice, such that whatever I have drawn here you need to do it in your mind. How? So okay, epoxide opening, so my nucleophile will attack from the bottom side, it will open up from the top side. If you understand this much, your job is done. So from that what you understand, okay, then there will be no change of the methyl position, methyl will be bottom, so methyl bottom, here methyl top, so gone, here also top gone. So based on this much understanding, 50% options are gone. This is called process of elimination, very helpful for solving MCQs. Now there is a question that, okay, option A versus option D, what? So nucleophile will attack here, nucleophile is attacking this less bulky carbon, means this butyl group will attach here. Is it really attached here with respect to methyl? So answer is no, so this is gone. You don't need to think about the relative stereochemistry also, basic sense also you can get, but generally student I don't recommend, this much knowledge is not enough. You need to know the complete thing, because nobody can guarantee what is going to appear in the exam hall. So complete knowledge is essential. So I believe if you study in this way, it will be easier for you. So this is the overall discussion. I believe this video may be useful. And if you really consider the content of my channel is worthy, then please help this channel to grow. And for any doubt regarding the logo of my channel, please read this part. Your doubt will be clear. So see you in my next video. Bye-bye.